The present and the unborn generations of the United States and the world are heirs to one of the greatest energy discoveries of man, nuclear energy. Accompanying the tremendous advantages of this discovery are certain potential risks to health and life. As small as these risks are, the government has the responsibility of assuring that the health and lives of people are protected, while the advantages of nuclear energy are being developed. Nuclear energy has already been put to use in many ways, as a source of heat for production of light and power. In cities, in industry, and for the propulsion of ships. It is used for experimental purposes in agriculture and to develop stronger strains of disease and weather-resistant food crops. Another great area of development for nuclear energy is, of course, medical research. Radioiodine has been found to be an effective treatment for hyperthyroidism, to give but one example. It is used for the control or relief of some diseases, and these uses will, of course, be greatly extended and improved in time. New programs of the Atomic Energy Commission and other agencies are designed to expand the usefulness of nuclear energy. Before work is begun on any of these programs, the government thoroughly evaluates the health and safety factors, often for several years, until it is assured that the project. Three major programs planned are: 1, aerospace nuclear reactor tests; 2, the Plowshare program for the peaceful uses of nuclear explosives; and 3, the seismic research program for the detection of underground nuclear detonations. The first of these programs, the aerospace nuclear reactor test at the Nevada test site, includes the development of a nuclear engine to propel rockets into outer space, and the development of a reactor for use in a nuclear ramjet engine to power a vehicle at supersonic speeds within the atmosphere. The Plowshare program covers several different fields. One is the development of a new source of power to supplement the rapidly diminishing supply of oil, coal, and gas. Today, reactor plants can provide an alternate source of power from nuclear energy. However, this power is now expensive because of the initial cost of the plants. In the Atomic Energy Commission's effort to find additional sources of power, one of the Plowshare's experiments involves investigation of the problems in the underground storage of heat produced by nuclear explosions, and the recovery of this energy to provide electrical power. Industrial expansion. Other objectives of the Plowshare program are to study the possibility of producing isotopes in these underground explosions, to aid in the economical recovery of minerals upon which the expanding industries of the world depend, and to explore safety techniques and economic feasibility of using nuclear explosions for excavation purposes in the building of harbors and canals. The Seismic Research Program is designed to improve methods of detecting and identifying underground detonations by seismic recordings, and to determine the wave ray patterns in the immediate vicinity of the site and at other stations in the seismic network. To differentiate between underground explosions, earthquakes, or subterranean tremors of similar intensity is a major difficulty. In the development of the Seismic Research Program, it is necessary to determine the characteristics of the seismic waves from an underground nuclear explosion at seismic stations all over the world. The Department of Defense plays a primary role in the Seismic Research Program, with full assistance of the Atomic Energy Commission and other agencies. In the selection of an underground test site, a series of test holes are drilled in a predetermined pattern. Known quantities of chemical high explosives are placed in the test holes and later detonated. Mobile seismographic units stationed at measured distances from the test holes pick up and record the resulting shock waves. Seismic recordings of the Earth's underground tremors are made from each detonation in the test holes. Here, the explosion was made by chemical high explosives relatively close to the surface. Seismic recordings produce considerable data on the underground geologic strata and hydrologic formations. These data contribute to the final site selection before preparations are made for nuclear detonations. In seismic research and other programs where the explosions are deep underground, no radioactivity is expected to reach the atmosphere as a result of the detonations. But the possibility that radiation may vent through cannot be overlooked. Safety precautions, such as collection of water samples from deep wells at the site area and from private wells and other water sources, will be used to determine if significant contamination reached water supplies. Health and safety precautions to protect workers at the site will include the use of film badges and monitoring for possible surface radiation. For the protection of the people in the vicinity, ground crews will monitor for radioactivity in adjacent communities. And at nearby facilities before and after each test. In implementing the three programs and to accomplish their objectives, the Atomic Energy Commission is coordinating the Public Safety Program with the Public Health Service, Weather Bureau, Geological Survey, Coast and Geodetic Survey, Bureau of Mines, and various other agencies. The efforts of these agencies, together with those of state health departments, form a giant network that protects the health of the people. The Public Health Service Off-Site Radiological Safety Staff provides radiation surveillance support for the nuclear energy exploration programs. This support requires the cooperation of everyone involved. It requires taking every reasonable precaution to safeguard the environment and health of the people who might be within the range of radiation effects from tests. Officers of the Division of Radiological Health of the Public Health Service are concerned with the broad spectrum of health problems related to nuclear radiation. They are assigned to various activities and participate in nuclear energy exploration operating programs. The Weather Bureau acts in a staff capacity to provide data on pertinent weather and meteorological conditions. It predicts surface radiation patterns prior to the test. In fact, right up to the last minute before the detonation. Pre-test weather briefings consider the possibility of downwind, rain, or snow, the wind direction and speed at various altitudes, and high and low pressure areas. Although the possibility of radiation escaping from contained underground nuclear detonations is small, a close check is made on meteorological conditions as an additional safety precaution. In concert with the Weather Bureau in this capacity, the Public Health Service provides the Atomic Energy Commission with data on the actual measurements of the surface radiation field and patterns, and how they may have deviated from the predicted estimates after each event. The U.S. Geological Survey plays an important part in nuclear energy exploration programs in the investigation of the technical problems relating to the selection of a site which will provide maximum safety for the public. Special emphasis is given to the location of water-bearing strata. Samples of rock, ore and minerals are collected from the site area and examined to provide data on the underground geological strata and formations. Geologists also take water flow measurements in strata surrounding the proposed test area and advise on the relation between surface and groundwater. The Coast and Geodetic Survey also assists in providing recorded data on seismic vibrations emanating from underground explosions in the Plowshare and seismic research programs. The seismometer is activated by the ground motions of varying intensities.